Algebra 1, this is 5.4. 5.4 is now we're going to actually solve inequalities again, but this time we're going to be introduced to the idea of compound inequalities. Compound inequalities just kind of says there's more than two inequalities at the same time. So it's going to have an and or in it. So ands are only true, guys, when both inequalities are true. This is called the intersection, where the graphs would overlap. So an and problem is where the two inequalities would actually run at each other, and it'd be where they overlap. An or statement is true as long as one of them is true. This is called the union. I'm going to put all of the options on the table, so therefore the graphs go in opposite directions, because I can be over here or I can be over here. So ands, when we're talking about ands, the first one, the intersections, you generally have graphs that have two endpoints and you shade towards the middle. Ors, you still have two endpoints, but you generally will shade in opposite directions. Okay? Because I can be here in this group, or I can be in this group. Versus an and, I have to be in both groups. So that means, whoops, did not mean to do that. That means that if I'm at this dot, I'm actually would be traveling like this direction. But if I was at this dot, I'd be traveling in this direction. And what they do is they overlap in the middle where both of them exist. So kind of going back to that amusement park idea, that if you were going to go to an amusement park and they had a ride that said you had to be at least 6 feet tall. Well, that would probably eliminate quite a number of us, especially in the class, including myself. I wouldn't be able to go on the ride. Now, if it said you have to be at least 6 feet tall or you have to be 18 years or older, then I could go on the ride because I'm part of the other group. I'm over 18. You guys would still probably not be able to do that. Now, if it said and, so you had to be 6 feet tall and be over 18, then I still would not be able to ride the ride because I do not qualify under both of those. So that's how an and or an or problem is dealt with. So here we go. The first problem is an and, so therefore you have to be where they're both, where they're going to overlap. And the second problem there is also an and, just slightly set up a different way. Here's the cool thing. If I'm given two inequalities, I am just going to solve them separately. So I'm going to add 3 to get y by itself. So y is greater than or equal to -8. Going to bring the word and along for the ride. Oh, here's a cool thing. I just have to add 3 again because I got to get y by itself. So y is less than or equal to -5. So what I'm going to do is I'm going to, on the same number line, I'm going to put -8 and I'm going to put -5. Now be very careful. Sometimes these numbers here could be in a different order. Just happens to be -8 is smaller than -5, so they do kind of jive when I go below here. Notice that in both cases they're equal to, so I will have a solid dot for both. And here I have to say, hey, y is greater than -8. If I go on this number line, 0 would be way over here, somewhere. So is 0 greater than or equal to -8? And you're like, yeah, it is. I have to go that way. Now, I'm not going to shade quite yet. I just kind of make these little arrows to say, oh, I'm going to shade towards -5. Then I come over here and say, is 0 less than or equal to -5? And you're like, well, no, that's not true. I actually have to go shade the other way. So look, they're pointing at each other. Well, here's the thing. If it's an and problem, they have to be where they overlap. And if you notice that if the -8 goes this way and -5 goes this way, they will shade together in the middle, and that is where your answer lies. Now here's a cool thing. When I have to go state my answer, I actually can state it as -8 is less than or equal to y is less than or equal to -5. And that's another way to show an and problem is one continuous inequality. And if you look at example 2, that is one continuous inequality. Now, in problem 2, you will recognize that there's stuff in the middle and then there's stuff on the ends. Here's the cool rule. What I do to the ends, I have to do to the middle. Or what I do to the middle, I have to do to the ends. I have to get r by itself. It's r plus 7. To get r by itself, I will subtract 7 to the middle. If I subtract 7 to the middle, I will subtract 7 to the ends. 6 minus 7 is negative 1. I am not going to do anything with my inequalities because I am not multiplying or dividing by a negative. I very well could, though. Here's the cool thing with these ones. If I'm already given this particular compound inequality right here, where negative 1 is less than or equal to r is less than 3, I can then easily say I'm always going to go right to the middle. And close dot at negative 1, but an open dot at 3. If you don't believe me, check a point like 0 is in the middle. 0 is definitely bigger than negative 1, but it is also less than 3. You shade in the middle. So that's how you can do those problems. The next group is an OR, as you can see. And ORs are going to graph the other way. They're going to go graph away from each other. So notice that in both of these examples, there is none of that extra long compound inequality where you have it all in one place. Because ORs can never be like that. They're always going away. So again, I will graph these or solve these the exact same way. I'll subtract 1, so a is less than 3. Or, I have to add 1 this time, so a is greater than or equal to 4. So when I go to graph these, 3 is here, 4. 3 is an open circle. 4 is a closed circle. 0 is over here, so I get to use that. Is 0 less than 3? Absolutely. Shade it up. Boom. Going away. Is 0 greater than or equal to 4? No. So I have to shade that way. So I am shading away from each other. That's an OR statement. I can be less than 3 or greater than 4 or greater than or equal to 4. And so the same thing's going to happen here with part B. So, hey, look at this. This one is already done. I don't have to do anything. That's awesome. But I do have to get the x in the second group by itself, so I have to get rid of that 2. So subtract 2. So I get 4x is less than 8. Oh, that's not done yet. Divide by 4. I am not dividing by a negative. Leave the inequality alone. So that goes along for the ride with the x is less than or equal to 9, and x is less than 2. And so, look, the order is different now. 2 is over here, while 9 is over here. 9 is a closed dot. 2 is the open dot. 0 is over here. I'll use it. Is 0 less than 9? Yes. Interesting. So I'm going to shade this way. Now that's kind of scary because what I'm looking at here is the fact that I'm going towards my other dot. Generally, they go away from each other. So I'm kind of breaking that rule that I initially started off with. But don't worry, it's okay. We got an OR. So I can still be in this group or I can be in the other group. I have to test the other dot. 0 less than 2. Oh yeah, that is also here. That's true. So this one with 2 is going to shade to the left. I'm going to change colors real quick so that we can see this. I have to be less than 9 as well. Now, because this is an OR statement, I can actually be in this red group down here, or I can be in the purple group. Well, do you recognize that the purple group also includes all of the red? So the actual answer to this problem can be just x is less than or equal to 9. Because it includes the group of the other side and the parts in the middle. So it's just kind of weird that way it works out. Most of your problems will not work this way. Most of your problems will be shade this way and shade that way. Okay, so be thinking of that. And your homework is those 4 problems. Have a great day.